or Santa Cruz, probably to pronounce it perfectly, who is a professor of the history of consciousness. And I think the reason to invite Dimitris here, well, connects to different points. I think to connect to the Polycrisis network, partly because the Polycrisis network is concerned to think with and through crises in a different way. And I think Dimitris' work, since he works at the interaction of science and technology studies, sociocultural theory, constructivist photography, and political ecology, was an interesting mix of transdisciplinary science, or social science, if we can call it this way, and humanities, that could certainly help us to enhance some ways response to that concerns that we have. His research looks at technoscience and socio-ecological transformation. And in the context of Polycrisis network, it's really, since we're seeking to step aside, or say, there's some way to use a Foucauldian term, pas de côté, I think it's great to have him to reconsider what we mean by crisis, but also how can we live in the current era. I think I come to the work of Dimitris through his very interesting book published at Duke University Press called Experimental Practice, Technoscience and Alterontologies, or I don't know, Alterontologies, and More Than Social Movement, which I think was a very interesting piece of work. And I think a central tenet of his work is really the exploration of alternative mode of practice, which I think all of us are concerned with, certainly, to generate knowledge. And what do we mean by this knowledge? He has also co-edited Ecological Reparation, Repair, Remediation and Resurgence in a Social and Environmental Conflict, which was published last year at Bristol University Press. And he's also, he has co-produced a YouTube channel called Ecological Reparation, which in fact discuss this kind of work that engaged with remediating and repairing, as well as claiming reparation for damage to more than human ecologies. And I believe that, in this sort of somehow catastrophic environment within which we found ourselves with the non-human life, this is an absolute interest to have someone who can help us thinking that through. So, Dimitris, I think we're pretty happy to have you with us, especially knowing that you're in California and we have all this time difference. I mean, now I would say that the rest is all yours, so you can discuss, you can start your talk right now.
Yeah. Thank you very much. Thank you for the invitation. I'm happy to be here. I was, I thought that I wanted to accept this invitation because I wanted to be in discussion with you, but also to think through the concept of the polycrisis that I hadn't engaged before. And because of that, I decided to present just some thoughts and how trying to think how my work connects to this idea and how it responds to the theoretical questions that polycrisis as an idea and as a concept, and perhaps also as a way of doing research poses. So this is, I'd like to see this as a two-way conversation. And as I said, this is not a formal talk. These are just some thoughts. So I wanted to start from the research and with a project I've been doing for the past probably 5 years or so. And this is a project on the idea of substance and on substances. And I investigate also green chemicals and materials. And I wanted to start from an example from this work, or a case study from this work, which comes actually from a place which is very close to Leeds, from York, and the Green Chemistry Center of Excellence in the University of York, where I spent quite some time there doing field work and talking to the people and to the colleagues. With a solvent, and perhaps as an introduction, a solvent is the non-active substance in countless, really countless commercial and industrial and everyday solutions. So it is a non-active substance that facilitates the activity of the main ingredients and active substances. And you can think, if you have a tea, you can think of the water in your tea as a solvent that carries the actual substance, which is the tea with it and delivers it. So we use a lot of solvents, and most of them are very, very hazardous. I wanted to focus on one of them, which is called NMP. It is derived from butane and is a component of natural gas and crude oil. So it comes essentially as a petrochemical derivative, is a petrochemical compound, and is used very widely in various industries. Now, it is, for example, a key material in manufacturing of lithium-ion batteries, in paint removers, in coating strippers, in electronic cleaning, and it is used widely in the production of petrochemicals and plastics. Now, the problem with NMP is that it is a substance of very high concern because of its environmental and health safety effects. It has a very severe developmental toxicity profile, also neurotoxicity, organ toxicity, irritation of different organs, skins, eyes, throat, and of course, environmental and ecological effects. The problem is also that it is very easily absorbed through skin contact and through inhalation of vapors. And because of that, there are many attempts to replace the solvent with an alternative solvent or with different alternative solvents. And one of them is the one that I want to focus in this example that I'm using today, and it is called DHL, is dihydrolevoglucosenone. And this was invented, literally invented, in the Green Chemist Center of Excellence in the University of York. It is derived from biomass and food waste and could be used as a replacement for NMP. And it is not only environmentally more sustainable, not sustainable, but more sustainable, but it is also safer and has a lower toxicity profile. So now the problem is that this alternative solvent, and this specific one, but most of them, they are, although they are growing very fast, they are very slow in comparison to the conventional solvents that we use. And they are not yet high volume commodity solvents. And here starts the problem, and this highlights the problem we find ourselves when we are thinking with substances and substance. To give you a scope of this, and here I made some notes and I'll read through these numbers. So we have, of course, an enormous amount of organic synthetic compounds that we use, more than 95% of what you see around you, and everything you touch, probably everything you wear, and many of the things that are already in your body contain some form of synthetic compounds, but less than 10% of them are environmentally, socially, or clinically benign. To give you an example, and the numbers are staggering, in bulk petrochemical production, we generate 1 kilogram of waste for 10 kilograms of product. So 1 kilogram for every 10 kilograms of product in bulk petrochemical production. To give you another example, In fine chemicals, such as medicine, we generate 1,000 kilograms of hazardous waste for every 10 kilograms of active pharmaceutical ingredient for the API. So 1,000 kilograms for every 10. And you can think of these numbers also in the scale of actual production. So in 2022, there were 2.4 billion metric tons of petrochemicals produced, an increase of more than 40% from 2018 in only 4 years. Now, the chemical industry relies almost exclusively on fossil fuels, and more than 99% of its feedstocks are derived from oil. It is also the world's most energy-intensive industry and is the third largest CO2 emitter. And to put all this in perspective, the demand for primary chemicals is projected to increase by 40 to 60% by 2050. In these conditions, a transition to a sustainable non-toxic chemistry is not optional. It is truly an imperative, but it is also extremely difficult. So this is a crisis, and we are in a crisis. It is an ecological crisis. It is an industrial crisis. It is a scientific crisis in some sense, because we don't have enough knowledge to produce all and to create all these alternative materials and substances. It is a crisis of governance and regulation. It is a crisis of publics and a crisis of consumers. So what they select, especially because not every solvent or not every alternative product that we have does exactly the same as the conventional one. So we need to change a lot of things in how we do things and accept different functionalities in order to be able to accept alternative substances. It is, of course, an economic crisis in the sense that it is driven only by certain metrics and not others. And it is also a geopolitical crisis because it very much relies on a practice of extractivism in order to be to operate and to create the materials. So it's a polycrisis. It's definitely a form of interconnected and entangled dimensions that have an effect, a critical effect, severe effects across many parts of social and ecological and geological spheres. So now, how does this sheer number of crises oblige us to think differently? And that's the question I wanted to ask when Sebastian, you wrote to me. I thought, I'd like to think this through this project. I don't think that I managed to do that, but that's because it's more complex than I thought. But my question is, so how does this number of interconnected crises oblige us to think differently? And does an extended and intensive crisis across multiple domains of life, let's say economic and social and geopolitical and ecological and so on, means that we must adopt a wide approach for a possible solution? And it is often argued that if the crisis is, let's say, multidisciplinary, then the approach to the solutions should be also multidisciplinary. And what does it mean? What does it mean to approach something, a solution, as a multidisciplinary in order to reflect the existence of something across different registers of crises that we encounter? So do we engage with its domain differently, or as a whole? Do we do it sequentially, or all in parallel, or as a system? And of course, multiple disciplines contribute multiple knowledges and different knowledges. But I wonder, is there an integration, and what kind of integration there is, and how does this happen? And perhaps is integration possible? So in systems thinking, we tend to incorporate many layers, but usually what happens is that we tend to highlight this one specific contradiction that defines a system. So there is one systemic structure that is believed to capture the essence of a system. And we have a lot of these grand explanations or the contradictions that explain a whole system. So we think systemically, but we arrive to this single one contradiction. You have labor versus capital, growth versus no growth or degrowth, value-driven productionism versus ecological care, financialization and real economic activity, the West and the East, global North and global South, and so on. So in these systems, there are these contradictions. And I want to call the in a heuristic way, so to call this contradiction that we often arrive as, or that some people often arrive when they are thinking through systems as the primary contradiction, the one that drives all the other. So a crisis might be systemic, so we might have many crises in different parts of a larger system or across different domains, but the views to analyze them are often not systemic at the end, but they prioritize a specific contradiction in one disciplines, in one discipline, rather than across disciplines. And I think this is the problem where I'm struggling how to think and what is the methodology for doing research when you engage with polycrisis. And you could say, in a perverse way, in this systemic way of thinking, a polycrisis, there is often this one dimension that has the primacy and doesn't allow the rest of the issues to be resolved. So while you would resolve other issues in other domains in some way or another, there is this attractor, this one contradiction that attracts and actually blocks the others of being resolved. So the problem that I see here, the problem with contradiction, is not that it is not true or it might not exist in a certain field or in a certain domain, but that it is a universalizing disciplinary principle that aligns all the remaining ambivalencies, conflicts, problems, issues, crises in one or another way. So it aligns all of them and locks them into this one view. So it is this universalizing gesture in this primary contradiction that erases difference. That is, I think, key in understanding the poly before the crisis, so the polycrisis. And although I haven't read this for many years, but I thought of Hegel, who believed that contradiction is the rule of the true. So it's through contradiction you arrive to truthfulness. And I have many concerns with this. But even if you say, okay, Hegel might be right here, but he might be right not for the reason I think he was thinking that this is the case. So not because contradiction in some way underlies rational thought, as he believed, and is necessary to produce truth through rational thought. So it's not because of that, but because contradiction establishes a specific view of the world as universal. And then in this sense, it establishes the condition of for its truthfulness. So by making itself prevalent or preeminent in a certain field, it establishes also the conditions to be judged, and that's the universal gesture that I find difficult in thinking with this primary contradiction. So I arrived to my argument here, or to the first argument here, that I think we need to refute this idea of the primacy of a certain domain or a certain discipline or a certain argument or contradiction, if you want, and not because it's not helpful in certain moments to think with these contradictions or even to think in disciplinary domains. Also not because it's not important, but because it forces us to this universalist canonical view of thinking a very diverse field that we encounter when we think through the polycrisis. So instead of disciplinary thinking and its derivatives, and sometimes instead also of interdisciplinarity that connects fields but not necessarily bringing them truly together, so I'm thinking of a non-disciplinary approach. So rather than disciplinarity or even interdisciplinarity, I'm thinking of non-disciplinarity. And here again, I want to say it's not a question that interdisciplinary research or even disciplinary research is not important. Is more about the refusal of the primacy. And if you take this seriously, to refuse the primacy of one contradiction or one principle, then there is a serious issue of how we conduct research and what interdisciplinarity means. So the alternative now to this systemic way of thinking, to systemic disciplinarity, is not to embrace fragmentation. So you say, okay, we cannot bring all this together. We don't want to have one universalizing principle or contradiction. We leave them fragmented. The alternative that I think emerges from a non-disciplinary approach is to be grounded. So it's not to be fragmented, but to be grounded. And I want to develop this idea of being grounded in a problem or in an issue that we encounter, for example, the one that I mentioned before, not by rejecting knowledge in emerging disciplines, because this is part of the current historical formations of knowledge production that we have. So far from it is not saying disciplines are not necessary, or they are not, they don't contribute to solve the issues that we are trying to solve. It is to say that the engagement with a problem, I think, doesn't start from these either universalizing principles or disciplinary formations, but from the very core of the problem itself. It is an approach that grounds the problem in what is the most crucial, what is the exit path of a certain situation that we try to resolve. And I want to go to move to my second argument and to close with that. I want to think with the examples that I used before about alternative solvents and alternative substances. So the conditions for a novel alternative solvent assembles itself in different ways when, for example, we do lab scale research, or we try to put a compound in a demonstrator, or to elevate it to the scale of demonstration, or to scale it up and move it to early production, or to full production, or to make it a consumer product that circulates. So in all these different levels, every time a substance assembles, brings together all these different factors that allow it to exist. And these are very different than the factors that are brought when this product is, for example, manufactured at a test scale, or manufactured for production, or circulating and used for different applications. So, for example, in lab scale, we ask questions about which feedstocks are we going to use, and which specific processes? What about heat, and what about time, and how long is the reaction? Is it how much energy it uses? Which techniques are we going to use? Are we going to use microwave to heat something up, or a different technique? What are the implications? What pressure, and what does it mean, the pressure? Can we handle pressures, and up to what extent? For how long? Or is the reaction atom economic? So does it consume all the atoms that we put in the initial reaction in order to be sustainable until the end of the reaction, or does it produce a lot of unused atoms that we need somehow to discard afterwards and find ways to do that? Can we reduce the step of a reaction? Every reaction has several steps. So all these are questions that happen, and they are always very, very specific. There is an importance of specificity, which is perhaps one way to think alternatively about this primacy of a contradiction. When you start from a grounded problem, you start thinking of the specificity of these questions. So these questions are very different when, let's say, the solvent that I mentioned before, DHL, moves to production scale, where we have very different problems. We have issues of standardization, we have toxicity metrics, we have LCAs, we have public regulation questions, we have process engineering and questions about storage and about industrial facilities. We have questions about entrepreneurship and financial viability. And perhaps in this case, we have a lot of important questions about biomass and where does it come from, why it is used, where was it produced. So in this level, we have very, very different questions that come to make this substance possible and actually existent. And these are very different, because you would say that we talk almost about two different substances, and there is a lot of epistemological questions here that I cannot discuss now, but there are a question about when does its substance change, and how do we approach it as it moves through different domains and scales and environments. And then you can go even further when you think of all the feedstocks that are needed to produce this alternative solvent, and you start asking questions. Okay, how far did the biomass come from? So what about transport? And what about energy for transport? And what about efficiency in the way the feedstocks, so this biomass that we use for alternative solvents, where does it come from? And who works in the fields? And what are the working conditions in the fields where biomass is produced? And what are the questions of exploitation or racism in the fields? And how does this affect the actual substance itself in its production? And you can do another move and think of the afterlife of all the solvents, because this is probably what is not thought. for much of the products we use. So what about the afterlife? So where does it go? How far does it go? What is happening with the derivatives that are created through the different processes and different factors that play a role when these substances are released in the environment? So there is a question of afterlife. And this creates, again, fully different conditions into understanding. So I'm saying this example in order to visualize this being grounded in the actual problem that we investigate, rather than approaching the problem through one single disciplinary perspective or from the view of a primary driving contradiction. And I'm thinking here of substances that creates, in a certain way, the conditions of their own existence as they create themselves. And this happens by bringing together a lot of humans and non-humans in order to make this happen. And I think, Sebastian, you used a term that I found very helpful to think this. You used the term of subtle potentials that take place in the moment and in the existence of these substances, actually of every substance. And these are moments, you say, that of pure transformation, of emerging unexpectedness that realize alternatives to what seems like an inescapable and homogeneous future. So these are the subtle potentials that are in part, and they help us create each specific domain where a substance exists. In my work, I used the term of milieu in order to understand the chronotope, so the space-time where different forces and materials and affects come together in order to, perhaps we can use here also the term from Teilhard de Chardin, converge. So there is a convergence of things that allow a substance to exist. And this is the milieu. So the milieu is not the environment. It has the substance itself. And without it, no substance would exist. But every substance exists in a milieu and is also different because of that. And it is concentrated in it. And you would think of a milieu not as a scale. So the milieu of a lab experimental substance is not, it has a lot of scales that are far more greater. So it incorporates questions about energy or questions about sustainability. It incorporates questions about feedstocks and where they come from. So different scales are nested, if you want, in each one of the milieu, of a milieu. So in the milieu, you have different scales. In a certain way, you have many different crises expressed, but they are also very specific. So this is an approach to polycrisis that is grounded in the problems or problematics that we engage with, and we approach them through what comes together to create these milieus. And I would move perhaps to finish here, so that the milieu is simultaneously situational, so it's a very specific situation that allows it to hold and to exist, but is environmental, bringing together environmental factors. It is always and decidedly more than human. It exists through more than human action, but also through human agency and presence. It isn't, on a Haraway's word, nature cultural. It is 100% natural and 100% cultural. So not 60, 40, 50, 50, 70, 30, and so on. But it is absolutely both, nature cultural. It is one. It brings together larger ecological issues, but in experiential ways. So by concentrating them in the specific questions that are needed in order to make a milieu for a substance happen. So I use now the milieu as a way of thinking, an approach, an epistemological or a methodological, probably, approach to a crisis where we don't have a primacy of something, we don't have a primacy of a certain type of knowledge or of a discipline. We don't even bring two disciplines or three disciplines, or whatever the number is, in discussion in order to approach the problem, but we unfold the problem from itself. And here the problem of solvents is the problem of neurotoxicity, of environmental toxicity. So it's a toxicological problem. So that's the starting point to unfold this intensity, and started creating a milieu by bringing together different actors that might contribute in creating something that is less toxic. And as we move, this creates already a milieu, because we need to think which feedstocks, how much heat, how much energy, how many atoms, which other materials or compounds are going to use. Is it going to be catalytic? Is it going to be this or that? So it creates this milieu, and as it creates this milieu, it allows it to pose other questions and to move to another dimension or another milieu where you start thinking, perhaps biomass, but which type of biomass and where does it come from? And then assembles a different set of actors as we move through that, and so on. So a milieu is a way of thinking about producing something, but thinking about the context of the production itself. It's simultaneously the subject and object of research. And I would argue that this is something that ecological movements, traditional knowledge systems, even you would say many of the, let's say, peasant-driven agroecological practices that engage with the production of alternative materials, or indigenous eco-cosmologies, they always incorporate the milieu in the making of the whichever substances or materials they engage with. So in a certain way, the milieu brings us, it becomes elemental, and it connects different formations of matter, and it brings them together. So I wanted to think of this more as a multi-elementalism, as a multidisciplinarity. So as a multi-elementalism in the sense that whichever scale, and we said that different scales exist in the milieu, which scale you have, whichever scale is connected and nested in the milieu, it allows you to produce and to condense many different material, social, political, ecological, cultural dimensions in its elemental existence. So rather than disciplinary thinking, I'm interested in grounding knowledge in milieus and their subtle potentials. And rather than multidisciplinarity, I'm thinking with multi-elementalism. Thank you.
So thank you, Dimitris, for this wonderful, interesting, certainly thought-provoking talk. I was wondering whether there's anyone, I don't know if there's a question from the room or anyone online who would like to kick up some of the question for Dimitris. Dimitri, sorry. Laura, yeah? Yeah, I think you should. No, I mean, if you don't mind. Laura is also fronting the Polycrisis network with me and another colleague called Jazz. So.
Hi, thank you so much for that. I really enjoyed it, and that the idea of the kind of the universalization of particular products as problems through a fundamental contradiction. Really, I'm going to be thinking about that for a while. I work on nuclear weapons, actually, on nuclear stuff, and I think this has really sparked some things in my head. So that's really really great. Thank you. Actually, my question is actually a more kind of prosaic one, which is the project that you set out. To what extent can this be done through the modern university, through its institutions, through kind of publishing its kind of disciplinary journals, its funding structure, all of this? To what extent is this a project that you can see going through the structures of knowledge production that we have now? Thanks.
Thank you very much. This is this is a crucial question, and this is also a very complex question. So I'll start by saying something, because this is also a question that I receive when I present some of these materials quite often, because it's for me, for myself, but for many people, difficult to think. So when you try to think not in disciplinary ways, how can this be done? And this question comes often, and I pose it to myself. And then I often go back to some of the materials from my fieldwork and the interviews. So as part of this project, I did, I think, more than 50 interviews with some very prominent green chemists and several other interviews with environmental activists, and I spent quite a lot of time in chemistry labs, including the one in York, in Nottingham, in Bath, and so on. So, and in these interviews, one of the questions and one of the topics for the discussion was, so what made you think of green chemistry and the necessity or the potential of developing alternative greener, because it's not green, it's greener in some extent or another, so greener materials, compounds, or substances. And none, and I would say literally none of the answers is an answer that says, this is part of my disciplinary formation, this is part of a debate in the discipline. So people have other reasons for thinking this. And there are other reasons that made them engage with the creation of these alternative substances. And this, probably for me, it was serendipitous, because green chemistry is a new field. So it exists for the past 30 years or 20 years. So I could interview the people who started them and spend some time with them in their labs and talk to them, while for other fields that have been much longer, it would be more difficult to see how they happen. But I found it really astonishing that everybody has a different explanation why they started doing research. And in very difficult conditions, in conditions where funding for green chemistry was scarce or non-existent, actually, in conditions where the identity of the field was challenged, and this created a lot of ruptures within the field that they still exist, actually, and is far from resolved, all these issues. So it creates this situation where people move and they do something that doesn't come from the discipline, but is defining for their work and for the materials they engage with. And you have answers. It was the ecological movement. It was the oil crisis. A lot of people moved to think of alternative materials because they were studying in the 60s and 70s and with the oil crisis. So strangely enough, while we think that a lot of these things happen through disciplinary processes, a lot of, on the other hand, a lot of the I don't know, the motivation for doing certain type of research is coming from elsewhere. So I would say within science itself, within disciplinary science, you could even argue that the milieu is always necessary in order to create an environment. So it's not positive or negative. It is a way of allowing you to be reflexive, so to bring the conditions of the production of a material in what you do. Now, in traditional chemistry, for example, that is the field of this project, or the field where I do this project and I do my research, the milieu is always there because they need to incorporate parts of the milieu in order to create effective processes. They leave other parts of the milieu and they eradicate other parts of the milieu, and mostly consciously. So we need to leave questions of alternative feedstock, or the afterlife is never part of a reaction. So the question of the milieu is when you start thinking with it. And I don't want to make, because we can use many alternative concepts. It's not the concept that matters here. It's not about the milieu. So because it happens that I use it, is not, the concept is not important here. What is important is to say that in every step of creating a molecule, you incorporate the milieu in it. And the more you do it, or the more it happens, the more it creates a different pathway for this molecule to exist in alternative ways. And if you go as far as thinking, I don't know, factors that go far beyond the actual reaction, you start bringing this in. And in traditional chemistry, you start seeing a lot of people talking about life cycle analysis, for example. It doesn't happen all the time. Actually, it happens less often than it should, definitely. But this is a way of thinking the milieu. I think is a limited way, but it is a way of thinking the milieu and bringing it in the reaction that you create. So I would say, as with things, also with this, things are complex and they coexist. Many different ways of creating knowledge coexist together, and there are more that are more restrictive and disciplinary, but in many places, and when they happen, they incorporate other alternatives, non-dominant, let's say, ways of producing knowledge. And in some cases, these ways of producing knowledge become stronger and influence a lot the discipline and change it, possibly, as it happens, and others not. So there is a lot of traffic between these. That's what I'm probably trying to say, is not either or. Either you do a kind of, let's say, milieu-grounded practice or research, or you do something that it is abstract disciplinary. But there is a lot of traffic between this already within the disciplines.
Thanks for this, Dimitri. So, if I just jump on what Laura has highlighted, which I think is interesting, would it not? I mean, because to go for this grounded perspective, I'm wondering whether, because obviously the work you've done on chemistry, which is also very interesting because chemistry is about emergences, right? So there's emergence, reactions, things that are kind of suddenly coming in. So they flux, they're coming in, they're showing that they exist. Now, there's something that seemed to me rather important that may come also from science and technology studies, in the sense that Maybe if STS as a field, or a transdisciplinary field as we can call it, would maybe document more the philosophy of doing work, through the practice of sciences. Now I think we would really be able to put a light on, in fact, this milieu that you described, that even Canguilhem was seeing, pretty much at the beginning when he was talking about the milieu, although, I mean, what you mean, it's also linked to maybe von obsecure Umwelt concept at the same time, there's a lot of similarity. But what I mean is that through this understanding that science was far more than the disciplinary aspect that Laura was mentioning, in the sense that we're not trapped, but we're imposed to work in, we have tended also to follow the course of what pays off in terms of research, but maybe less to document, in fact, this kind of, you were saying fragments that you like less, but I would say these fragments of, or these elements, actually, that are coming from the research of sciences, that in fact show that it is a form of philosophical inquiry, but just through different form of practice, no?
I think absolutely, and probably there is a lot of work in STS. A lot of colleagues try to show all this, uncertainty and creativity and non-replicability of the actual core practices when you create this knowledge, that it is in a certain way very artisanal. There is an artisanal form these are, because it is very artisanal, it is also, and it is very also transversal and transmaterial. So you need to have, your technologies there, and you need to have your body in the right position, and you need to have the conditions right, and you need to have the non-human others cooperating and doing the work that they need to do, and the molecules flowing in the right way, and the electric currents being as you want. So you need all that stuff, and this is a very artisanal moment where you necessarily think with the milieu, because you create the milieu for something to exist. You don't think with a compound. You don't think with the abstract reaction. You think with the milieu that makes it. And this is an artisanal moment. But of course, because of all these other connections, because the milieu is one, but there are many others as molecules leave your lab and go somewhere else. And they get standardized, they get used a lot, you create canons of knowledge, and then the milieu starts being left out as a way of thinking. So you are right, and I think a lot of people, of course, Bruno Latour in Science in Action, Isabel Stengers in the invention of modern science, Donna in the OncoMouse, Donna Haraway, my colleague here in Santa Cruz, in the OncoMouse book, and so on, and Karin Knott-Cetina, and there are so many colleagues and friends working and trying to show how does all this contribute to the making of something. And yeah, so absolutely, it's there all the way from the beginning.
That's quite interesting. And I'm wondering whether there are questions online as well, or here from the crowd.
No, there's nothing here online.
Oh, there's nothing. I don't know. And Dimitri, you have to sneak in. You're on your bicycle or drive your car. I suppose it's the US to go to your campus, or when you need to leave now, or.
I need to leave at 9. I'm teaching at 9:30 up in the campus. I'll get on my bike and cycle up the campus for my class.
I understand. So fair enough. I mean, I had a couple of other questions, but maybe I'll send you an email. And because I think what you were saying about system analysis, and yesterday we were talking about this actually. So Laura and I. So it's kind of interesting. I mean, there was very interesting point that we need to I mean, certainly to be involved in a wider discussion, I suppose. But well, since you have to go very soon to leave us, I mean, we'd like to thank you again. I mean, this was, was very interesting. And hopefully, there's something interesting coming from this seminar for you as well, at least from the conversation. And we'll keep in touch and let you know what's happening with the network. And I would say that most people here, those who attended, at least, are happy to be in here. So again, thank you so much for your time and for this very interesting talk for sure.
And I'd like to thank you for first of all, for connecting me to the network, but also allowing me to think with a concept that I hadn't engaged before. Possibly I need to engage more, but I see that also as a possibility to continue discussing this. So I'd be happy to, to stay in touch and to talk in different ways and formats. And I'd be happy to hear how this develops and how the network develops.
Absolutely.
Sounds very interesting. Yeah. So let's continue talking.
Absolutely. Yeah. Well, thank you so much. And have a nice class and speak to you soon.
Thank you. Thank you. Bye-bye. Bye.